Voyager 1, NASA's farthest-reaching passenger spacecraft ***, continues its amazing journey through space, transmitting data flawlessly from far away. For almost 50 years, this astounding space investigation has upset how we might interpret space. However, the spacecraft has recently sent back troubling data to Earth, shocking the entire space community. Are these alarming symptoms brought on by a technical glitch or by something more substantial? Come along with us as we find out the truth about these exchanges. Starting from the dawn of mankind, researchers have been interested by the secrets that lie past our divine limits. The early launches of space probes, such as Explorer 1 and Explorer 2, as well as other spectacular missions, were prompted by this interest. These long-talked-about achievements started with the send-off of Adventure 2 from NASA's Kennedy Space Center on August 21, 1977. Small spacecraft, the twins weighed 720 kilograms each, were launched during a rare alignment of the outer planets. These daring explorers took many different paths and traveled at different speeds throughout their incredible journey. On December 15, 1977, Explorer 1 took off from its parallel track as a result of course changes. Since then, Explorer 1 has grown into a valuable resource that offers a wealth of information and reveals space's secrets. Let's take a look at the amazing images that were taken by the rocket during its 1978 Jovian axial imaging mission before getting into the amazing new discovery that Explorer 1 made that astonished the entire space industry. Explorer sent numerous images back to Earth, 265 million kilometers away. With 3,750 images, a 100-hour project began in January 1979 to record an impressive time-lapse film that allowed us to see Jupiter's beautiful dance in vivid detail. Months after the fact, Pilgrim 1 meandered into the Jovian moon framework and made an amazing revelation: the presence of a little ring around Jupiter and 2 new moons. We should get to know the lovely planet of Jupiter. To ensure a secure approach and avoid a collision with Titan, one of Saturn's moons, adjustments were made. Pioneer 1 proceeded with its circle around Saturn and found 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. Toward the finish of the Saturn mission, researchers chose to end the planetary mission of examination by pushing Voyager 1 and 2 past the boundaries of our planetary framework, voyaging 200 million miles, 325 million kilometers, in January 1990. The interstellar research mission was launched in another chapter. During this time, Explorer 1 took some of the most well-known photographs ever taken, including images of the Sun and the majority of the planets. Dr. Isaac Newton, a well-known astronomer, was an important factor in expanding the missions beyond their initial objectives. Sagan Carl. As a member of the imaging team on the mission, Doctor as a final gift to humanity, Sagan struggled to capture one last set of images. Regardless, this work took care of on February 14, 1990, when Wayfarer 1, 6 billion kilometers from the Sun, started a visual excursion known as the birth photograph of a planetary gathering. The spacecraft's impressive collection of 670 images was further enhanced by these amazing images, which totaled 60. Wind speeds of more than 1,300 meters per second were recorded by Voyager 2 when it came into contact with Neptune, making it the fastest wind ever recorded in the planetary zone. At the point when the rocket came extremely close to Neptune's blue methane gas, we got an astounding perspective on this far-off divine body. It is interesting to note that Triton, Neptune's largest moon, was found to be one of the coldest places in our group of planets, with a surface temperature of -391 degrees Fahrenheit. Our imaginations were also captivated by Triton's unusual features, such as its gas-spitting ice volcanoes that send ice particles up to 5 miles into space. Our understanding of the incredible variety and complexity of celestial bodies in the outermost reaches of our planetary system has been enhanced by these discoveries. In any case, stay put. Voyager 1 has made quite possibly of its most unnerving disclosure. First, let's examine the accomplishments of the past 45 years. The accomplishments of the 2 Pilgrim missions are actually normal. Their first observations of Jupiter's and Saturn's moons more than 40 years ago shocked scientists and disproved previous theories about these far-off worlds. These moons, which were once thought to be dormant and gloomy like our moon, have been found to be teeming with human activity. During its journey, Explorer 2 accomplished a number of remarkable feats. When it became the first vehicle to fly by Uranus in 1986, the space shuttle made history. It transited Neptune 3 years later, completing yet another amazing feat. This is the only rocket that has traveled that way thus far. NASA has taken several steps to extend the project's lifespan as the Explorer missions continue. These daring studies will be able to continue into the following decade because components and heaters that are not required to conserve energy have been eliminated in recent years. Their mission is expected to come to an end in 2030. For the researchers and specialists who have been engaged with this astonishing task all along, the finish of the examination project is a snapshot of pride and a sensation of misery. Their dedication and exertion have surpassed expectations. Many scientists and space enthusiasts have been inspired by the research's data, which has yielded a wealth of information and scientific discoveries. In addition to being space probes, Explorer 1 and Explorer 2 were meticulously designed as stable platforms that rotate more than 15 times slower than an hour. The spacecraft's ability to capture images and data as it traveled through infinity of space was limited by this design decision. Their remarkable imaging capabilities astonished both scientists and the general public prior to their encounters with exoplanets. Before the spacecraft entered Jupiter's atmosphere, it began sending images of the planet. At NASA's Jet Propulsion Laboratory, audiences were enthralled by these early images of the Great Red Spot, which showed clouds that were swirling. However, what initially caught our attention was the discovery of active volcanoes on Jupiter's moon Io. Io, marginally bigger than Earth's moon, was viewed as the most volcanic body in the planetary group. The shape of the various signals that the spacecraft's instruments picked up from Io confirmed this. The surface of the high volcanic columns was formed by the volcano's eruption. Io, one of the most well-known volcanoes, has 10 times the strength of Mount St. Helens. Before entering interstellar space, the spacecraft's cameras were turned off to save power and memory, but the images they took did not show Mercury or Mars for some reason. Notwithstanding the interstellar tests Pioneer 1 and Traveler 2, NASA has likewise worked other renowned rockets like Explorer 10, Explorer 11, and New Skylines. On February 17, 1998, Explorer 1 passed Voyager 10, making Voyager 10 the most distant spacecraft. On August 25, 2012, Explorer 1 entered interstellar space after 14 more years of solo travel. NASA revealed this remarkable feat in 2013, despite the fact that no spacecraft was able to observe it. What conditions ensured these missions' success? An extremely basic strategy: the helper elements of energy. Because of these efforts, Explorer 1 and Explorer 2 were able to move forward with their daring missions to explore the farthest reaches of the universe. Spacecraft require lift and the assistance of energy in addition to their straightforward propulsion systems in order to reach these faraway locations and gather valuable data. Imagine that two daring rockets, Voyager 1 and Voyager 2, are about to begin their epic journey through the planetary system in our own backyard. They collaborate with a few of our own planets in a celestial dance rather than relying on their own machines. Using the force of these enormous stars to propel themselves, the heavy planets joined together to dance. They were able to quickly travel to various locations and save a lot of fuel using this method. When we examine the fundamentals of the gravity slingshot, also known as the gravity sling, we discover that the goal of this operation is to transfer some of the energy from the Earth to the spacecraft as it moves. Imagine that Explorer 1 is getting close to Jupiter, which has a huge atmosphere and is pulled in the same direction by gravity. Explorer 1 moved precisely and at the right speed and angle through Jupiter. The spacecraft was pulled in by Jupiter's force, which increased its speed and lifted it. It is extremely significant and is contributing greatly. Negative rotation from Explorer 1's orbit could have caused the inclination deviation if Explorer 1 had approached Jupiter at the wrong angle or speed. It's hard to handle the level of precision required. However, the brilliant minds behind these missions have frequently utilized these potent aids, leading the Explorer spacecraft on a remarkable journey through the planetary system in our own backyard. Explorer 2, for instance, made use of Saturn and Jupiter to reach Neptune and Uranus. The great journey is only possible because of these gravity aids. These active aid efforts have resulted in a lot of success for observation missions.